Now this you can see is divergent from the notes and learning goals. If you look on the notes and learning goals, you'll see that this falls in the divergent in the divergent area. On the notes and learning goals for the convergence basic lesson. But there's also another way to do it. You can use a comparison test. So let me show you how I would figure this out if I didn't have the notes and learning goals. Okay, so basically the idea here is we're going to use this rule where if you have, now this only works if A and B are both bigger than positive, or both bigger than 0. So let's say we have 0 is less than A is less than B. Okay. So this tells us that 1 over B is less than 1 over A. Right, so now for n equals 2 to infinity, ln n is less than n. Right, so using this same rule, I should probably give myself a little more room here. Ln n is less than n. Remember, ln is much smaller. Excuse me. So that tells us that 1 over n is less than 1 over ln n. So that tells us that the sum and now we can use a comparison test. We know that this is divergent. So if you're bigger than something that's not narrowing in on anything, there's no way you could narrow in on anything. So it's divergent. The way I remember it is smaller than convergent is convergent. Bigger than divergent is divergent. And you see here we're definitely bigger than divergent, so we're divergent.